This is this continuation of the last lecture. Well, here you have seen and to for the representation of the vector, you require two things: straight line and arrowhead. So in the last lecture, I have given you one example that 100-meter distance towards east, and you have seen uh, how can we draw that paper. The second example I'm taking a bit difficult and uh, displacement, force, velocity, acceleration, all are vector quantities. I'm taking here 200 Newton force acting on a body, 200 Newton force acting on a body at 60 degree along x-axis. It's this example a different example than previous one. At 200 Newton, force is acting on a body at 60 degree along x-axis. If you talk in the direction, so you can say that it is the 60 degree in northeast direction from along two things. You can say along x-axis and you can say northeast. So this is student, you know very clearly now that two things you required, and here this is a vector and two things are clearly shown here. 200 Newton is some magnitude and 60 degree is the angle. So here that scale you need. Then you can take any scale according to your convenience. For example, I say that 1 centimeter is equal to 100 Newton. So 2 centimeter line will be required, which is a small line segment. So take reasonable that if you take 50 Newton, so for 50 Newton for 200, you need 4 centimeter line scale. And I think the 4 centimeter line scale is the reasonable line scale. And second thing, you require the direction scale because of that the direction is given. It's a vector, so keep in mind that when you draw the direction is when you solve these types of questions, so two things you have to draw on write on paper first, and uh, then we show the rest working. Mm, so here two things are shown here: scale, and this is your scale. 1 centimeter line is equal to say 50 Newton, and secondly the direction scale. So when you will do the work, so these two things must mention on the paper, uh, then start the rest of the working. So according to this scale, you need 50 Newton line. So student, this is the origin. This is the origin over here. So you can say that here this is your region, and this is the east is here, and say this east is nothing but the x-axis also, and north is the vertical line. So this is the y-axis also. So you can see here clearly in the direction scale that the north is the y-axis and the east is on the x-axis. And you need to draw along x-axis. First of all, you draw. It's a different question. First of all, you have to draw the angle. So keep your protector over here, uh, here, and this is the central point of the protector, and put the 60 at 60, put the point at 60 degree, and draw uh, any line, straight line of any length over here. But that will show the uh, that will show the 60 degree along along x-axis. So first you draw the line at 60-degree angle of any length. Now use compass and open your compass 4 centimeter. Keep over here yourself, your compass keep over here at the point O and draw an arc 4 cm. Suppose that this is the 4 cm, but you will do, when you will do, you will take proper measurement and open your compass 4 cm and uh, draw an arc over here. So student, it must have some name. Say this point is say A. So here this is the vector. Put an arrow over here, and this is your vector OA along x-axis. This is the x-axis line, and this is the vector OA along x-axis at 60-degree. So how can you write that? This is the vector, this is the point O. So you can write here OA is a vector. OA is a vector 4 centimeter long. According to your scale, this is the 4 centimeter distance and length, and you can say that this 4 centimeter vector shows uh, 200 Newton force along x-axis at 60-degree. So this is a clear example when you have to draw angle. Uh, how can you draw the vector on a paper? So student, this is you can do the practice of the other questions also, that representation of a vector. So you know two things very clearly you need, and uh, how can we use that to solve. This is the example of that what is a vector, and vector must have some. You can see the slide that vector here in this slide, the tail and heads are shown and the direction shown. This is the length of the segment which shows the magnitude. Uh, 2 cm, 4 cm, and 6 cm. These are basically the magnitude towards east, towards west, towards north. This is the direction. Here, one example is shown over here. It is the vector 43 degrees southeast, and it has some magnitude also. So you can use the measurement or the graph paper to represent the vector on a paper. 43-degree is shown over here. So vector in 2 dimension and vector in 3 dimension possible. A vector is a mathematical quantity that has magnitude and direction. And vectors can be drawn in 2 dimension and 3 dimension. So a student, when you have the vector in 2 dimension, so there you need two ordered pair. For example, I say 3 and 2 are the ordered pair. And when you will draw on the graph paper, so this will be a line on the graph paper, and you say very clearly that this is the x-axis and this is y-axis. And for example, I'm going to draw these uh, points. This is 1, 2, and 3 on x-axis, and 1, 2 on y-axis. So you will come here. Probably you will get the point of intersection over here, and this is the origin, and this is the point A. And a student, when you draw the vector, you will get a line like that. This is a vector which has a uh, so this is the vector. I think the I'm drawing an rough, so you can draw on paper like that, here up to here, and it's an arrow. So this is a two is here. This is a two. This is one, and this is one, and this is a two, and this is one, and this is three. So, student, that's a OA is a vector. OA is a vector in two dimension because there are two ordered pair. If you have the vector in to draw the three dimension, so there will be three ordered pair and x, y, and z. This is x, y, z, it's a Cartesian system, and the vectors when you will have to draw, so you will have ordered pair. This is the vector OA, and this is the vector OA, uh, vector OA, 3 and 2. So vector OA, you can say that it is 3x plus 2y. And when you use simple direction with the vector, according to the definition, the vector must have some star magnitude and direction. Vector, this is the vector, and vector. Listen that I'm saying in words, and I'm writing. What I'm writing. This is the vector. Vector consists of magnitude, and vector consists of magnitude and arrow and direction. Vector consists of magnitude and direction. I am saying in words and writing in symbol. I am saying in words and writing in symbol. So again I am repeating it. A vector consists of magnitude and direction. Vector consists of magnitude. This is the vector, this is magnitude, and this is direction. So when you will have to write a vector in symbol, that it you can write like that. Student, you can use any symbol over here, vector v. When you say vector v, so make like that v, and vector consists of magnitude and unit. So you will, this is the sign of the magnitude of vector, and you say this is the vector sign, and for the direction there is the alphabet you can use b cap. This is b cap. So here your b cap is the direction vector. You can write here, this is the magnitude without this symbol also. So in that case, you will notice this is a vector, and it consists of the magnitude. So without sign, when you will write only a, so a will be the magnitude, and you can notice over here that uh, there is no vector sign on A because it's the magnitude. So if you have to write, show the magnitude, so you can show by two ways, either by this sign, but there should be a vector sign over the symbol A. And similarly here, if you are not writing the vector sign over the symbol over the symbol on capital A, so don't worry about that, but don't put here the this sign magnitude. It is already is a magnitude because there is no vector sign, so it's a magnitude. So you notice that I was saying in words and writing in alphabet that the vector consists of, again see here last a vector consists of magnitude and direction. So direction vector is shown by cap, a cap. So here this is the example that the vector in the say the direction of on x-axis and y-axis you can write by I and j. If the vector in two dimension, there are dimension vector. This is the I and j, and if there are three dimension, that will be I, j, k. So you can write here the OA is a vector 3xi, 3xi, and say plus 2yj, plus 2yj. So generally you can write the vector in x and y form. This is the vector OA. This is 3, 2xi and 3yj. This is j. J is the direction vector along xy axis and I is the direction vector along x axis. So student, generally you can write the vector, any position vector or resultant vector, whatever you can write like this. Vector consists of in two dimension I'm talking xi and yj, xi and y plus yj. And if we want to know the direction, if you want to know the say resultant vector and the direction, you can see this is the direction angle. So you can measure it geometrically by the help of the protector, but here we have another way. We can use the trigonometry, and we can find that this is the uh, vertical component and horizontal. So we can find this vector over here by the use of the Pythagoras theorem. We will see this thing here. We can see how can we find that r by the use of the Pythagoras theorem, and we will see in the separate lecture when we have to find the resultant vector. So the vector in uh, two dimension, vector in two dimension, it is clear. Vector in two dimension, and there are two ordered pair you need. You need two ordered pair, and if the vector in three dimension, you will require that three ordered pair. So vector in three dimension, you will require three ordered pairs x, y, and z. And this is the vector. Another you have seen this slide. So vector in two dimension, you have seen this is one other example very clearly mentioned over here that there are two A1 and A2 vector. A1 is the horizontal component of the vector and A2 is the vertical component of the vector. So this is the position vector is shown over here, and you have seen working in detail. I hope you understand this slide. And this is the vector in three dimension. The vector in three dimension x components are x, y, and z. Vector was in two dimension. I was explaining the vector in two dimension where there we need component x and y, but here there are three axes we need and x, y, and z. So this slide is clearly mentioned here, and x component and y component and z component. You can see clearly x, y, and z axis three dimension, and the supposition vector p that is shown over here by this violet color, and this is the x, and this is y, this is z, very clearly shown over here. And you can see that for the three dimension vector you need three axes. And another good example that ijk. Uh, the ijk is the direction scale, a direction vector ijk along x, y, and z axis. So this is a final slide and very clearly shown over here. When you can see that it's a p and a vector op. This is the o and p, and p op is in 3 dimension. So px is the x component and py is the y component, which is in green color and red color, and pz is the z component of the vector p. P is any position vector. For your convenience, there are three color used here. That p x component of the p is shown in red color, and y component shown here over here in green color, and the z component in blue. You can see clearly to represent the OP. The OP is basically say position vector, and X is the red color. So students see very clearly that this is X and Y and Z. See my cursor, X, Y, and Z. And this is the X. This vector is parallel to this vector, and uh, this is the green color vector, and say blue color vector. So you can say the green dotted line points over here, the vector parallel to y, and this is x, y, and z. So OP is the vector which shows the p component of y. Here, C is working. When you say the vector in 3 dimension, you need first of all, I'm just revising that slide, and you can see here this is a x, uh, this is a y, and this is a z. So this is suppose your 3 dimension axis, and here this is a I is the direction vector of x. Um, this is a I is a direction vector of say your x, and y is the direction vector uh, say j, I j, and this is k is the direction vector of z. This is the k. So how many things you require to draw a vector in 3 dimension? Three ordered pair. Three ordered pair you require: x, y, and z. As you can take any number for to draw the vector, so that you can understand well. A student, I'm taking 4. Suppose I'm taking 4, 3, 3, and 8. These are the points I'm going to draw a vector in 3 dimension to show the location of a body, suppose. So when I say 4, 3, and 8, it means it is 4i, 4i, I say because the I is x point, and plus the second order pair show the y point. See here, y is 3, and this is 3j, 3j. Again, you can see here, say this is 3j, and 8k plus 8k plus 8k. I say this 8k. So, student, you say that these are the ordered pair x, y, z, and I have taken to explain As for an example, 4, 3, and 8 points, and these say the vector A, which is the position vector according to this ordered pair. Very clearly, I showed here very clearly that vector A is 4i plus 3j 8k. Now see on the diagram that 4. Suppose that this is the see my cursor, that is in starting point, that and I'm going to draw this x-axis. This is 4 up to here. Suppose 4, and this is say 3. So I'm using a different color for the x, for the y. So this is say y. Y is say 3. Okay, and again see here x, y, and now the z. I'm using another for again. I'm using different color for say this. I say this is the z. Again say the joining O A, and this is say 3j 3y, and this is say the z is 8. This is say 8. Student, you can see very clearly. This is say 4. This is say 3, and this is say 8. These were the three say coordinates of x and y and z. When you see the whole view, that x x YZ ordered pair, 4, 3, 8 as an example. And when you write in vector, that vector form, that 4i plus 3j, 4i, 3j plus 8k. And when you join these component, this is 4i, means on x-axis, and 3, 3j, 3j on y-axis, and say uh, 3j on y-axis and z. Now, finally, when you will join a resultant vector in other separate lecture, I will explain the types of vector like position vector, free vector, null vector, unit vector, direction vector, resultant vector. So these are the types of kinds of vectors. So I'll give you the separate lecture on it. But we know that when we join the initial to the final point, so that uh, that is say the resultant vector. So I'm going to join the resultant vector. I'm going to show the resultant vector O and A. You know this is the net displacement, and arrow must be here. This is the point A. So student, you can see clearly that in the green color, your OA means this is the A. Vector A is shown over here. You can write OA with OA, or you can write A only. So this is the 4i plus 3j plus 8k is a vector. This was an example that vector in three dimension. Uh, Clearly, I hope you understand this example, that in this slide, that x, the p is a position vector OP, and p x, py, and pz. And the last slide I have shown the working by taking an example of the ordered pair. So in the next lecture, inshallah, we will discuss how can we find the magnitude and direction of the resultant vector. Hope you understand this lecture, vector representation. how many things we required, and two dimension for in two dimension vector, how many ordered pair, how many components are required, and in three dimension, how many axes and components are required, and what do you mean by the vector in two dimension and three dimension. Hope you understand. So the remaining content will explain in the next class, inshallah.